One simple way to start to understand how vectors work and how they can be added and subtracted, and why it's not just as simple as adding and subtracting the numbers, why the direction matters, is to first talk about the ideas of distance and displacement. In later chapters, displacement, and to some respect distance, will be important in measuring other variables, but for now, we're just going to talk about them alone. When we talk about the distance that someone travels, we talk about a person's physical movement throughout a trip. So if you're standing at the end of your road and you walk to the store, and the store's 5 miles away, so I mean it's a walk, I guess you could drive to the store. So you drive to the store that's 5 miles away, you've traveled a distance of 5 miles. You get some snacks, you drive home, you've traveled a distance of another 5 miles, for a total distance of 10 miles. That's the total physical distance that you've traveled throughout your trip. In general, we understand the concept of distance. Now, displacement is instead a measurement of the difference between the initial position and the final position of an object. So in the previous example, if you leave your house and go to the store and you travel 5 miles, for that one part of the trip you have a displacement of 5 miles. And let's say the store is north of you. So you've traveled 5 miles north. Your displacement is now 5 miles north. When you travel back, you travel home, you travel 5 miles south. So your displacement is 5 miles south. We know from what we said before that the total distance you traveled was 10 miles, but in this case, when you get to the end of your trip, now the difference between your initial position where you started from, your house, and your final position where you ended up, your house, is 0. And in that case, your displacement is 0. The 5 miles north and the 5 miles south cancel out. And though you've traveled a distance of 10 miles, your displacement is 0. In terms of physics, distance is essentially measured as a scalar quantity. It is an amount and a unit, but it doesn't include any direction. It doesn't take into account where you started or where you stopped. Displacement, on the other hand, takes those things into account. And because it takes those things into account, we can use it to measure things about how objects move, because it accounts for the direction as well. So displacement is a vector, and it takes into account the direction that you travel. And that vector always points from your initial position to your final position. So let's assume that you travel 3 miles east and then 4 miles north. It's obvious that if you walk that path, you've traveled 7 miles. But that's not your displacement. In order to figure out what the displacement would be, we have to talk a little bit more